Okay, hello, Allie and Danny. I'm recording lesson 1-3 for you. This is line segments, and we just started, so we're talking about betweenness of points. And I said betweenness of points is something, it's a concept. It sounds really sophisticated, but it's actually kind of stupid. Oh, you can't see. Oh. You think you should be able to see? I'm still on my other computer. There we go. Betweenness of points. All right, so here's what betweenness of points means. Ready? Let's say I have a line segment. Just do this little rough sketch right here, and it'll be easy. All right, here is A, here is B. I'm going to put C in the middle. Now, I'm going to do this on purpose and put C not exactly in the middle. I'm going to put it in between, okay? Because I don't want you to be led to believe that this only works if C is exactly in the middle, all right? So this is what betweenness of points means. If this segment is 3 and this segment is 5, the whole segment is 8. That's what this means, right? So what they're saying is they say the length from A to C plus the length from C to B is equal to the length from A to B, or 8. Does that make sense? This chunk plus this chunk equals this chunk. Now, you can use that in reverse, like let's say I said this was 8 and this was 5, but didn't tell you this one, right? Could you figure out that that was 3? Okay, cool. So that is the betweenness of points. That sounds like very non-trivial, right? Okay. So there's that. AC plus CB equals AB. That's kind of how that works. All right, example 1. Find the measure from X to Z, right? Find the measure of XZ, that line segment, and there it is. Can you do it in your head? Maybe? Like 15.1, maybe. You can use a calculator if you don't need to. Is it 15.1? We add these two together. So this 11.3 is saying from here to here, 3.8 is saying from here to here. I add those two together and I get 15.1, and that is the answer. Good, good? Okay, do you know how to add fractions? Easy.
8 and 16.
Okay, so 2 plus 5 is 7. 7 tenths plus 9 tenths is 16 tenths, right? The bottom number stays the same. 7 plus 9 is 16, yeah? But 16 tenths is an improper fraction, right? So 16 tenths would be 1 and 6 tenths, but I already have 7. So that is 8 and 6 tenths, but 6 tenths will reduce, and that is 8 and 3/5. Final answer. If you can, that would be great. You won't have very many fractions that you'll have to reduce, but okay, do you see how that worked? Was that too fast? Okay, so you're just adding those, okay? Good, good? If by chance I go too fast and you're like, oh, wait a second, I didn't catch all that, I would totally go back for you. Okay. Yes, you can. Yes, you can. Okay, now this one is asking for QR. So I just said that, like, you can use this betweenness of points in reverse. This little piece right here is 16 and 5/8, right? This whole thing is 13 and 3/4. Yeah? So how do I do that? Subtract them. 13 and 3/4 minus 6 and 5/8. Okay? Now, I want to find a common denominator, right? So I want to make this 8. So how many 8s is 3/4? If I multiply by 2 to get from 4 to 8, I have to multiply by 2 to get 6/8, right? Okay? Now, I can just, without having to borrow, I can just subtract them. What's 13 minus 6? 7. What's 6/8 minus 5/8? 1/8. 7 and 1/8. Yeah? Do we remember how to do this? Otto's like, I want to use a calculator, or I want to convert them to a decimal first, right?
No, it's easy.
No, it's easy? Okay. All right. Perfect. You're a fraction guy. So I lied when I said Otto's terrible at fractions, because you're good at fractions.
I got
Okay.
funny stories.
Yay! And those are all mediums?
Yep.
Cool. All right, got it.
You're not doing
Awesome.
very many signs.
Yeah, I know. That's really handy.
It's
And we do have one that is a coach, right? But we're not putting, are we putting coach on the back of hers? No? No, okay.
Just
All right.
leave it.
Just leave it. Just leave it. She can ask if she wants it put on. We can always put it on at any time. Okay, now we get to geometry, which incorporates a little bit of algebra 2. Boo. Right? Betweenness of points. So here we have this going on. How far is it from here to here?
4x. Oh. We don't know yet.
We don't know yet. They call it x, right? How far is it from here to here?
C, or 2.
2x plus 3, right? And from here to here is 4x minus 12. So how do I figure out what x is?
It's 3. You have to subtract the add them.
So the two smaller pieces, this x, that first chunk, plus the second chunk makes the third, like, big chunk, right? X plus 2x plus 3 is equal to 4x minus 12. Do you see what I just did? The two smaller pieces added together equal the bigger piece, right? Okay, and now I'm going to do math. So on this side, how many terms do you have over here? Like, how many pieces are there? 3 terms, right? Like this term, this term, this term, right? Okay, I'm going to start combining like terms, okay? X and 2x, I can put those together. What does that make?
3x. No, 2x squared.
3x squared.
X times 2x would be 2x squared. But if I'm adding, like, 1 apple plus 2 apples is 3 apples. 3x, right? Plus 3 equals 4x minus 12. Okay, then what? Here's my equal sign.
You minus the 3 across.
You want to the 3 or the 3x? I always get my x's together first.
Oh. Minus the 4.
Minus 3, and in real life, you don't want to ever put your x's in the same room. Okay. 3 equals, what's 4x minus 3x?
X
1x, right? Or just x. Minus 12, then what?
plus 12.
Add the 12 over.
X equals 15.
So x is 15.
Can I see the first step to that, please?
Can you see the first step?
So you add the bottom 2, and that equals the top one?
Yes. Yes. So this guy is this piece. This guy is this piece. And you add those two together and you make the full piece. So if you want to, like, do some math in your head before you write it down, I know that x plus 2x plus 3 is 3x plus 3. And 3x plus 3 is equal to 4x minus 12. And you do all the math, right? Okay? Good, good? Confusion? Was that hard? No, not too bad? Okay. All right. Are we good? Are we good? Moving on. Let's go to, are we on example 4 and that's it? No, we got more. Ooh. Okay. Example 4. Daryl is visiting the Space Needle in Seattle, Washington. Anybody ever been there? I've been to the top of him.
That's scary.
Yeah. Like, I've been here. And it's, yeah, looking out in the window, you're like, oh gosh, we're up really high.
Are you able to go higher than that, like to the very top?
I don't think so. I think this is, like, the only place that you can go, like, just that viewing window. I'm sure they have, like, tech people that are up on the top, but I don't know. They won't let normal, regular peon people, like, go up there. Okay. He knows that the total height of the Space Needle is 605 feet. So I'm going to put that down here. They have a really good organizer here, 605. The distance from the ground to the observation deck is 10 feet more than 6 times the distance of the observation deck. 10 feet more than 6 times the distance. What does 10 feet more than 6 times the distance look like?
10 times 6x.
10 feet more. What's 10 feet more?
10 plus 6x.
Plus 10. Yeah, 6x plus 10, right? 10 feet more than 6 times the distance of the observation deck. So that's what this guy is. What's this guy right here? This guy is 10, this from here to here is 10 feet more than 6 times the observation deck. What is this?
That's your total height.
This is just my observation deck right here.
Oh, so
That's just x, right? So this guy is 6 times x plus 10. This guy is just x. Does that make sense? Because that's the length of the observation deck. All right, so we can solve this problem. Here we go. What should we write out for our equation? I'm going to put it over here. X plus 6x plus 10 equals 605. Those two pieces added together give me 605. All right, so now I'm over here. What should we put together? 6x and x makes 7x. All right? Plus 10 equals 605. Okay? Subtract the 10 over. Yep. So 7x equals 595. Perfect. And then divide by 7. Can you do that in your head? Can you try it? No? It is 80. No, don't tell me. It's not going to come out nicely.
63.
What? 595 divided by 7? No. What is it? 85. Oh, it does come out nicely. Yeah. 85 what? Feet? Is that feet? Yeah. Okay, so x is 85 feet. But is that what they were asking, though? Let's look and make sure. Help Daryl find the distance from the ground to the observation deck. Woo! Ground to observation deck is this guy right here. The observation deck is 85, right?
605 subtract by 80.
So you could do 605 minus 85, or I could plug 85 into here, right? And do 6 times 85 plus 10. Either way, it doesn't matter. It probably is easier to do the 605 minus the 85. What's that come out to be? 520? 520 feet. That's how tall that is up in the air. Yeah, nice. Very good, very good, very good, very good. Okay? All right. Last little bit right here. One more example, okay? We have something called line segment congruence. Do you know what the word congruent means? Congruent means same shape, same size. I'm going to write that down. Congruent equals same shape and same size. Now, if we're talking about a line segment, really a line segment can't have a different shape. So really we're talking about line segments being the same size or being the same length, really, right? The symbol for congruent, by the way, if you ever see this symbol, it's the equal sign with a little squiggle over top of it, like this guy right here. That's congruent. That's what congruent means. An equal sign with a little line over top of it. Okay, that means congruent. So this is telling me that A, B, and C, D are exactly the same length. Now, if they didn't tell me that, if they didn't put this piece of information here, I can look at this diagram and know that those are the same length. Because for one thing, they're both labeled 1.7, but also what else?
They have the line.
This little red, pink, whatever colored tick mark, that tells me that they're the same length. Right? If they ever have that little pink tick mark, that means those are exactly the same length, okay? So down here in this first example, how do I know that PQ, this distance, and this distance are the same? How do I know that they're the same? They have a little tick mark, right? Now, if that's true, if those two pieces are the same, Q is the midpoint, right? It's exactly in the middle between the two, right? Okay? So, how do I figure out what X is? Because they don't give me what the full thing is.
You have to take 6 plus 6 plus 20 plus the 2x.
But I don't know what it's equal to, though. If I add those together, right, like the two smaller pieces added together, I don't know what the big piece is. So what do I do? No?
Well, if you know they're the same, why don't you just take 2x plus 6 in parentheses squared times 2? So the same.
You started off
Set them equal.
set them equal to each other. Yeah, like this piece is going to be equal to that piece, right? Now, up above when we were doing those examples, right? Can I take these examples here? Let's see where I'm at right here. Can I say that this guy is the same as this one and set those equal to each other? No, because this guy was not in the middle, right? That's when I have to do this guy plus this guy equals that guy. But if I know that the two sides are equal, I can set them equal to each other, right? Okay? All right, so if those two guys are equal, what shall we do first?
Take the 2, like multiply it.
Yeah, distribute them through, right? Okay, what's 2 times x plus 6? 2x plus 12, right? And then I've got 6x plus 20. All right, let's do other x first. Nope, 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 nope. Yeah, I got to subtract the 2x from this side onto this side, right? Which makes 4x plus 20 equals 12. And then
4x equals
minus 20 minus 20. So 4x equals negative 8. And then divide by 4, and x is negative 2. Okay,
Does it matter which way we want to solve that though?
what do you mean?
Well, if I wanted to, since I know they're equal, could I just take one of the sides of the equations and multiply it by 2 and then simplify it from there? Does that not work?
So if you multiply this guy by like 2,
Yeah.
that gets you like 12x plus 40, but what are you going to set it equal to?
Maybe minus the 40 over and then divide it out.
Nope.
Can't do that.
Nope, because if you minus the 40 over, you're basically setting it equal to 0, right? Does that make sense? And it's not a length of 0. Good thought.
Thank you.
Okay. Now, a lot of people, is that what we're solving for, is x? Find the value of x. Okay, now, some people look at this and they're like, whoa, I must have done something wrong because I got a negative number and x can't be negative. Yeah, it can. This distance can't be negative, but if I plug -2 in here, am I going to get a negative number? If you plug -2 in here, 6 times -2 is -12 plus 20. It's going to be 8, right? That's still going to be positive. So I can get negative for an x just as long as the distance isn't negative. Does that make sense? Okay. If you plug it in, the distance is negative, maybe you did something wrong, right? Okay, good? Happy with that? Okay, that was a lot. Page 23. Woo 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 woo. 2 through 32, the evens, and then 40 and 48. Okay, sorry, that might be a little bit long, but some of them are just like, add these two together, subtract these two. So if you want to use a calculator, you totally can. 2 through 32 evens, and then number 40 and 48. It's always up here. Okay? Algebra 1. Yes. Yeah. I'm trying to think who it is. Yes, we go to lunch after this. Okay, goodbye, girls who are watching this video.